Hello, my name is François Bérard, and with my colleague Thibault Louis, we're coming from University of Grenoble-Alpes in France. So we'll be showing this sphere that gives you the illusion of holding a virtual object in your hands. And the system is very low latency, high resolution, high precision, and has stereo. So all this contributes to create a very strong feeling of presence of the virtual scene in your hand. So we use the system for various user studies to measure the benefit of the approach for human depth perception, for example, or human 6 degrees of freedom control. And we published paper in past conferences about that, but what you see here is only a video, so it's not as convincing as the real thing, because we cannot show stereo, for example, and you don't have the control on the viewpoint. So the only thing to really feel how it works is to try it, so please come see our demo.
Hello everyone, I'm Mikael Luminen from VTT Technical Research Center of Finland. The core of our application is a combination of our own 3D point cloud tracking solution and Google's AR Core. This results in a more robust tracking experience, as well as being less restricted. We use this to access information from a BIM information model, building information model, which we get from a commercial facility management this solution. You can find us in the demo room. We are the team with the small wooden house on the table. Thank you.
Grizdy. Hello everyone, I'm Dariusz Rumiński, and today I demonstrate Vibromotors Wearable. It's a mobile, lightweight and easy to wear device that can enhance MR application with tactile feedback. It runs Vibromotors while interacting with 3D objects. This device provides easy to use API. The application can control voltage by sending asynchronous HTTP requests. Here is the simple example of this request. So I will be very happy to demonstrate some demo few applications using this device. Thank you very much.
Hi, my name's Jonathan Hart. I'll be demonstrating sharing augmenting emotion in collaborative mixed reality. So basically what I'm doing is that I'm using a webcam to capture my face, detect the feature points, then using software to translate those feature points into expressions. And I'm basically putting them on the avatar. But the important difference is that you can also augment these emotions. So basically you can appear happier, or you can appear happy when you're sad, or you can express yourself as even a lion or a monster. And yeah, yesterday with the demo, but I think I've got like a 90% chance that I can guarantee it's working a lot better today. So yeah, please check me out. Thank you.
Hello everyone, my name is Yong Zhe. I'm from University of Clermont-Auvergne in France, and with Image, I'm so pleased to present to you our demo entitled Face Parsing for Mobile AR Application. Actually, we are attacking a problem which is called face parsing, which is segmenting different facial components on the face. Actually, we can imagine a lot of AR applications with this technology, for example, virtual makeup, facial animation, skin detection, or face morphing. Actually, we have optimized several aspects of our CNN model to run it on iPhone in real time. So please visit the stand number 7 in the demo room, and thank you very much.
Commander Rapapis reporting on Project Codename Holoreal. Yesterday at 0800 hours, we received intel that Isma will be under invasion by virtual robots. We are prepared, as our scientists have developed technology for us to be able to engage them over large-scale AR theaters. With this, we provide operatives with virtual drones to combat the enemy, and tools which include navigation and communication. However, the enemy is aware and targeting our virtual satellites. Your mission is clear: to defend these satellites. Operators, report for duty at the following times and dates. Dismissed.
My name is Carnel Vezio. I'm from the Computer Graphics and User Interfaces Lab at Columbia University, and I'm presenting a demo about exploring a music catalog. We do this what we call a hybrid user interface, which combines a head-worn display and a multi-touch panel. In the video you're seeing here, we're using a HoloLens with a 55-inch perceptive pixel display and a Leap Motion controller. In the demo we have at ISMAR, we're using a Oculus CV1, a Z Mini stereo camera, and a smaller flat panel display. What's key here is that we are co-registering the coordinate spaces of the head-worn display with the coordinate space of the touch panel. The music library is being powered by Spotify, so in a moment you'll hear a song from Daft Punk playing on the music. Okay, please come try out our demo. Thank you.
Hi, so we're presenting a collaborative SLAM approach that allows multiple agents to wander around an environment to construct locally consistent subscenes, which we then join to make a globally consistent large-scale map. This can be done using relatively low-cost hardware and allows us to reconstruct accurate maps interactively at a much greater scale than was previously the case. We stream images from each agent to a central server and reconstruct a map for each agent to make a subscene soup. Once all of the subscenes have been reconstructed, our pipeline uses camera relocalization to stitch them together. With multiple agents reconstructing the different subscenes in parallel, this process allows us to reconstruct a globally consistent model of an entire building in under half an hour. Our approach can also be used to join subscenes online while reconstruction continues. Come and visit our demo in number 10 to see more.
Hey, hi everyone. My name is. That's number 10. There is no number 10. Yeah. Hi everyone. My name is Javier Rodriguez Putfer from Cologne Intelligence and the University of Applied Science of Cologne. And what we are presenting here is a localization service based on using the sparse visual information from our core. What we are doing is just taking the point cloud and the camera image for calculating the binary descriptors and sending them to a backend where we can place a kind of place recognition. And with this information, we can be able to provide a localization on a previous acquired map. Yeah. So come over is the number 11. Thank you.
Just making sure that my slide actually plays on time. In the meantime, hello everyone. My name is Abraham Georgiadis. I'm the UX Engineering Community Manager for Mano Motion. That's right. So I'm here to present some of our students' work that I'm super proud of. Magestro is a Guitar Hero-like game with a twist. Yes, that's right. Those are actually like hand gestures being played on a single RGB camera of a regular phone. Our students have built this for AR and VR, and quite possibly will pretty much build it for any platform. So I highly urge you to come and check it out and play it, and check more of our tech. Thank you very much.
Good afternoon, everyone. My name is Salma. I'm representing Technicolor. So if you're interested or simply wonder what a realistic augmented reality running on tablet would look like, then just come to our demo and find out. We'll be able to play with this little bunny, turn on and off the lights, move them, and even shed some flashlight and see its appearance adapt online. So 3 words, realistic, dynamic, and very cool demo. I will see you there. Thank you.
Hello, I am Seiji Tsunezaki from Saitama University in Japan. We propose a system that can reproduce material appearance of real objects using mobile augmented reality. This system allows a user to manipulate a virtual object whose model is generated from the shape and the reflectance of a real object using his or her with 6 degrees of freedom. To realize natural interaction with virtual object, this system provides visual information that is consistent with the user's somatic sensation by displaying user perspective images on mobile display. The user can obtain the perception of materials from changes in gloss and varnish of the object by rotating and seeing the object. If you are interested in our work, please come to our demos. That's all. Thank you.
Hello everyone, this is Tomoki Kurahashi, a student in University of Tsukuba from Japan. We developed a capturing AR system. With our system, people with hearing impairment can see the conversation instead of hearing. The conversation is displayed next to the face with a speech balloon, like comic, manga. Our balloon rises little by little and eventually disappears. If you want to stop balloons moving or conversation, you can do it using the controller. So you will not miss the conversation. Also, you can look back the conversation above the speaker. By all means, please come to try our demonstration. Thank you for listening.
Hi, I'm Thomas and I'm from Graz University of Technology and I'm presenting our Shading Atlas streaming demo. So different setups for virtual reality suffer from limited performance, limited mobility or high latency. Our Shading Atlas streaming approach decouples rendering between a powerful server and a lightweight client. The client sends its current pose to the server, which shades potentially visible geometry into the Shading Atlas. This geometry is sent incrementally to the client together with the MPEG encoded Shading Atlas. The client then has to only render a fraction of the scene geometry together with a texture mapping from the Shading Atlas. The following scenes show example views in the corresponding Shading Atlas. Shading Atlas streaming can handle higher latencies than competing methods due to being able to sample more views from the Atlas. If you want to try it out and learn more, please come to our demo. Thanks.
Have fun.
For me, first of all, dopeness is what I like the most. Dopeness. People who want to make things as dope as possible.
Hi, my name is Hyung Kim, and our demo is named Swag after smartwatch-assisted gesture interaction for mixed reality HMDs. And our demo is focused on freehand virtual object manipulation in mixed reality environment, but robust object manipulation requires robust 6 degrees of freedom hand tracking, but it is a challenging problem because of the self-occlusion. So we reversed the use of smartwatch by getting the more reliable wrist orientation data and combined with camera-based 3D hand position data to manipulate 3D object. And also, we suggest a simple calibration method using a simple marker to calibrate between smartwatch and HMD coordinate frame. Okay, thank you.
The video's not playing. Okay. There's no sound. Anyway, sudden cardiac arrest is one of the most prominent diseases where victims are dependent on the help of bystanders which are not properly trained. We introduced Tutor, a system which can transform 2D RGB videos with minimal authoring input into 3D AR applications. We use OpenPose and Hand 3D to reconstruct a 3D trajectory with authoring input. The author can register the motion relatively to the human body. Please come to my demo and try to learn CPR again. Thank you.
Hi, my name is Kelvin and I'm from Rakuten. And earlier this year, we had a small exhibition of historic FC Barcelona jerseys at the Rakuten Cafe in Japan. And so the goal of this project was to create a mixed reality experience to give users a surprising and immersive experience about our brand, our collaboration with them. So this video shows the opening event for that exhibition, and you can also see our what the visitors saw at the mixed reality experience. So come on to our demo, and you can also experience the same demo. Thank you very much. I'll let you enjoy the video.
So hello everyone, Pascal Knieriem from LMU Munich, and today I present the work of my co-authors, also Francisco Kiss and Albrecht Schmidt. So it is a look inside, understanding the sum of looks through augmented reality. And what we did is helping physics students who have to learn about temperature distribution and thermal distribution in metals. And since these concepts we can't see temperature distributions, we used a thermal imager and streamed the live data of these to the HoloLens to visualize actually the temperature distribution of this experiment, which you can see here. So it's currently really hot since it's red, and you get this live data. So if you haven't managed to see this demo yesterday, please come to the demo booth and try it out. See you there. Thanks.
Okay, that's fine. So hi everyone, my name is Mathieu from Technicolor. So actually I will present today the work of my master student Glenn, who can be there today. So it's a diminished reality application running in real time on a mobile device. So if you have ever wondered how to remove real objects, make them fully transparent, or if you have ever dreamed you were invisible yourself, come to check the demo. Actually, right before the demo session, I scanned quickly my demo table and the surroundings, and we reused the 3D texture mesh to recover really large textured areas. We also support dynamic light changes. Hi, my student there. So please come to check the demo. People loved it yesterday. You will love it too today. Thanks.
Fuchs told us to either work license or displays. So we developed a remote collaboration system that uses then scene reconstruction. And for our demo, you get to be the local user wearing smart glasses and reconstructing the scene. And I, as a remote expert, then can give you instructions such as 3D drawings and 3D annotations. Or, for example, also segment objects from the scene and then use the created 3D mesh to create very simple animations that show you how to use a specific object or tool in order to perform the task. But most importantly, the remote expert has the advantage to be independent of the view of the local user and can navigate the scene in 6 degrees of freedom. Thank you.